So, Miss Savantika, significant digits, yeah. So Avantika, in last lecture also, what we had discussed was that usually in significant digits, yeah, significant figures, usually the problem that students face is about the zeros. Now there are, as we had discussed, we are just reviewing the lecture. So as we have discussed, so we have three kind of zeros. One are leading zeros, second are interior zeros, and third are trailing zeros. Miss Avantika, are we clear?
Yes.
So leading zeros, see the simplest are the interior zeros. Interior zeros are zeros which are struck between non-zero numbers. Are we clear?
Yeah.
So interior zeros would always be significant. Are we clear?
Yeah.
Okay. Now we come to the second part about the leading zeros. Leading zeros would be zeros on the left of a non-zero number. Are we clear, Avantika?
Yeah.
Zeros at the beginning of a number implies that you take the first non-zero number and look at the left. All the numbers would be leading zeros. Are we clear?
Yeah.
And leading zeros are not significant. Again, simple rule. Are we clear? Now the tricky part, frankly, this is where most of the students get stuck. The tricky part is the trailing zeros. Now, in trailing zeros, how we understand trailing zeros is that these trailing zeros are significant if and only if there is a decimal point. So there should be a decimal point like this. So if I see a number like 1.050, now this zero is an interior zero, and this zero is significant because there is a decimal point which is involved. Are we clear,
Yeah.
Avantika?
Yeah.
Okay. Again, if we look at number like this, 1.00 into 10 raised to power 3. Again, if I look at this number, the two zeros on the right have a decimal. That is why these trailing zeros are significant. Are we clear?
Yeah.
If you remember, last time we had discussed that this is called a scientific notation. Now, in scientific notation, what we had discussed was that this part can be ignored when we are looking at the significant digits. Are we clear?
Yeah.
And this is the format which is followed now. This is the format which is followed now. So 1.00, so there are three significant digits. But if there is a number like this, 10. Now 10 can be in this 10, this 0, if you see only 10, then this 0 won't be significant. This 0 can only be significant if you see either a number, either a symbol like this, or you see a symbol like this. Are we clear?
Yeah.
So if you find these special symbols, then this trailing 0 would be a significant digit. Are we clear, Avantika?
Yeah.
If there is no symbol, so for example, if there is a number like this, now these three and this one, they are not significant. They are not significant because there is no special symbol here. Are we clear, Avantika?
Yeah.
And usually, you know, this format, or this using a decimal like this or using a bar like this is a older way of writing. Now, if you want to write a number like this, you want to show that these three trailing zeros are actually significant, then this is preferably written in the form of a scientific notation like this. Are we clear? Because when we look at the scientific notation, then we are very clear. So what I'm trying to tell you is, and that is why this will become very important when you are doing practical work, is if now after your significant digits lecture, you should understand that 1 into 10 raised to power 3 and 1.00 into 10 raised to power 3 are two entirely different animals. Are we clear, Avantika?
Yeah.
Because 1 into 10 raised to power 3 has one significant digit, but 1.00 into 10 raised to power 3 has three significant digits. Are we clear about this or not?
Yeah.
So, for example, what CB is suggesting is that when you write the speed of light as 3 into 10 raised to power 8, when I look at this number, I know that there is only one significant digit. Avantika, are we clear?
Yeah.
But when you see something like 2.99 whatever into whatever, so for example, if I write this as 2.9 into 10 raised to power 3, then I know that there are two significant digits. Are we clear?
Yeah.
And in practical work, this becomes very important, because when you say 3 into 10 raised to power 8, then you know that there is a lot of approximation. But when you write something like 2.976432 1, latram patram, you know that precision is there. Are we clear, Avantika?
Yeah.
So that is why this becomes very important for us, especially from a practical, from a lab point of view. From the practical lab point of view, this becomes a very important topic. Are we clear, Avantika?
Yeah.
So that is why I had sent you this two lectures on vernier caliper and screw gauge also.
Yeah.
See, what happens usually is that in 9th and 10th class, now this batch was a COVID batch, so anyways you won't have done 9th, 10th vernier caliper or screw gauge. But in 11th and 12th, you will be required to use vernier caliper and screw gauge. And when you are noting the figures that you are noting a measurement, you should know the kind of precision that is there in the system. Are we clear or not?
Yes.
So when you write 1 into 10 raised to power 3 and when you write 1.00 into 10 raised to power 3, there is a value of difference between these two, because 1 into 10 raised to power 3 is a precision of one significant digit, but 1.00 has three significant digits. It is more precise than 1. Are we clear?
Yeah.
So when we were doing engineering, our professor used to have this class. Each of his class used to be at 3:27 p.m. or he used to say the class is at 5:03 p.m. So one day someone asked that why does he write class as 5:03 or 3:27 p.m. So then he told us that you know there are three significant digits in 3:27 p.m. So rather than saying the class is at 3:30, which is only approximately, but when you say 3.27, though 3:30 also has three significant digits. Is Avantika, are we clear or not? Are we getting the hang of the
Yeah.
concept or not? Yeah.
Yeah.
So now, fatafat, let us finish this off. So, as per the rule, this has five significant digits. Are we clear?
Yeah.
Because this is a trailing zero, and this zero has a decimal point. So there'll be five significant digits. Are we clear?
Yeah.
Oh, I'm sorry. There's six. Six.
6. Yeah.
Six here. I'm sorry. Now, if I look at number like this, there is no special symbol here. So that is why there are only two
Mm.
significant digits. Are we clear?
Yeah.
The special number is a number like this. If you see here, now I know that this is 5, 4, 2. There are six significant digits. Are we clear?
Yeah.
And what I'm telling you is that, nowadays, you will, this would be written like 5.42. I'm sorry, this would be written as 5.42 1, 2, 3 into 10 raised to power 5. Yeah. So automatically, when I write this in scientific notation, this has 1, 2, 3, 4, 5, 6, 6 significant digits. Are we clear?
Yeah.
So the point that I'm trying to make is, and you should be very, very clear about this, that in scientific, when you are writing the any number in terms of scientific notation, the number of significant digits should not change. What I'm trying to tell you is that if you try to write this in scientific notation, you should write this number as 1.2 into 10 raised to power 1, 2, 3, 4, 5. 1.2 into 10 raised to power 5. 1, 2, 3, 4, 5. Are we clear? Because in 120,000, there are two significant digits. And when I write this in 1.2 into 10 raised to power 5, again, there are only two significant digits because I will have to ignore this. Miss Avantika, have you
Yeah.
caught the point or not?
Yeah.
भाई से भी confusion है तो और बताओ. So the point that I'm trying to make is, let me repeat this point because this is a bit subtle point. The point that I'm trying to make is that there is 12,000 and there is 12,000.0. Yeah. So if I have to write this in terms of scientific notation, I will write this as 1.2 into 10 raised to power 1, 2, 3, 4. Why? Because here there are only two significant digits, and here also there are two significant digits. Ms. Avantika, are we clear?
Yeah.
But when I look at this, I understand that there are 2 plus 3, 5, 6 significant digits. So similarly, in scientific notation also, there should be how many? 6 significant digits. So 1, 2, 3, 4, 5, 6 into 10 raised to the power 1, 2, 3, 4. 1, 2, 3, 4. No, 1, 2, 3, 4, 5, 6. And this would be 1, 2, 3, 4. Are we clear?
Yeah.
Is it correct or have I made a mistake? This would be, yeah, it is fine. 2, 10 raised to power. Yeah, it is fine. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it is correct. Are we clear? So when I'm, reducing a number into scientific notation, I should be very clear about that I'm not changing the significant digits. Are we clear, Avantika?
Yeah.
So 3, 6, 7, 6, 2, 3, 4, 6, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 5, 3, 6, 1, 3, 6. This Avantika, are we clear?
Yeah.
Any doubt, any particular question that you want to discuss?
No. No. Nothing particular.
किसका? फोर्थ का? अरे हाँ, 5 होगा. बाकी चेक कर ले फटाफट. मिस Avantika, प्लीज चेक इफ आई हैव मेड अ मिस्टेक.
Yeah. 1 second.
आधे टाइम मैं अपनी साइज बना रहा होता हूँ घर बैठे. बाकी तो ठीक लग रहा है.
Yeah, sir.
And why we require, I'll tell you the deeper reason why we require this. See, finally, the important topic that we need to cover from a competition point of view is error analysis. So any competition that you are appearing for, so for example, if you are appearing for IIT JEE or you are appearing for NEET, this error analysis question will come. And error analysis usually starts with a very, very precise understanding of significant digits. Ms. Avanti, are we clear?
Yeah.
So after significant digits, we will be doing this rounding off. This is the next topic we'll be doing. After rounding off, we'll be doing addition, subtraction, multiplication, division of significant digits. And after this, we'll be going to error analysis. Now in error analysis, we will require a very good understanding of how significant digits behave. So every year, every competition, there is one question for error analysis, and that requires a very clear understanding of how significant digits are. The next topic that we'll be doing, rounding off, is also very important. Ms. Avantika, are we clear?
Yeah.
Uh, I will, of course, I'll discuss this topic. Don't worry about this. But without even my discussing, try to do this question from question 19 to 24th. You need to reduce the number to 3 significant digits. Try to do this.
Yeah.
हो तो सोच